Well, now we're starting to talk about how to convert between um, fractions, decimals, and percents. That's our whole unit. Lesson 6.1 is just taking decimals and converting them into fractions, which is actually one of the easier things to do. But let's talk about just a few terms that we need to know. Mixed number, you're already familiar with that from our previous unit. I've written down a few examples you should add to your notes. But these phrases right here, uh, a terminating decimal and a repeating decimal, you may be a little less familiar with. But a terminating decimal just means that it ends. That's what the word terminates means. So, given a few examples, even a number like 4, which is a whole number, is considered a terminating decimal. It's as if we had 4.0 after it. Then a repeating decimal is a decimal where a digit or more repeats. So I've written it a couple of different ways. The most typical way is to use the repeating bar over whatever repeats, but it can also be written with the ellipse, the dot, 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 once a pattern is shown. But it has to be clear what is repeating in what you write. Either way would be fine. What you don't want to do is just round a decimal that is repeating. So then you're going to see a little table here. These are just a few common fractions and their decimal equivalents, and they are ones that I suggest you memorize, and anytime you have to utilize these on any kind of assessment, for me, no work is necessary. In particular, 1/3 and 2/3 show up a lot, and there's actually going to be some more repeating decimals that we're going to memorize, and that's on handout number 2. Um, you can just read the little memory tip here a little bit later. Spend a little time getting familiar with these, the ones that you're not already familiar with. Probably 1/4 and 1/2 and 3/4 you already know. And then that only leaves the fifths that are left. Sorry, let's go to the next page. So let's talk about how you actually do the conversion, decimal to fraction. All you really have to do is know your place values. So I've given a couple of examples here with the steps kind of written out, and I suggest you read through those before continuing with the video, and then we'll work some problems together. So hopefully you've read through those steps, and then we'll work some problems together. So it asked that the first thing you needed to do was actually figure out what place was farthest to the right. So I've got tenths, hundredths, thousandths. 2 is in the thousandths place. So I take the number, put it over 1,000. There's no point in putting 0.62. And then all you have to do from there is use what we did in the last unit over fractions and simplify. Both are divisible by 2. 31 is prime. It does not go into 51, so we're done. If you have a whole number, you can just put that out there as part of your mixed number. 6 is in the tenths place. So you've got 7 and 6/10, but you're going to simplify it. Both are divisible by 2. So you get 3/5. And then our last one, the 2 is in the hundredths place. So you've got 6 and 92 100ths. 92 and 100 are actually both divisible by 4, but if you don't recognize that and you first just want to start by dividing by 2, of course you can. If I divide 100 by 2, I would get 50. 90 divided by 2 is 45, so 92 divided by 2 would be 46. And then both of those are even, so we'll divide by 2 again. We get 23 over 25. And then we have it. So you can see the process is really not too tough. This is going to be your favorite section of conversions right here, most likely. So if you want to try the next 3 on your own and then come back to the video, great, or just watch along with me. So you got to be careful when there's a lot of digits like this one. First, I just put my 2, put my bar. I know I have a 5 on top, but it's tenths, hundredths, thousandths, 10,000ths. Then I know I need to simplify that. 5 goes into itself once, 5 goes into 10 2 times, and then there's 3 more zeros. So there's really no point in going over and doing long division on that. I would say that these problems are actually involve steps, but the step really is just showing that this becomes this. It's actually the simplifying part. So on 7 we've got 32 and 8. Hopefully you put over 100. Well, 8 doesn't go into 100, but 4 goes into both of these. So you should have gotten 32 and 2 over 25. And then on this repeating one, you do not need to show how to convert 0.6 repeating into a fraction. You just need to memorize that 0.6 repeating is 2/3, and that's on that table that we showed on the previous page. So this would be one where there's no work necessary, just 2 and 2/3. One more page, quick problems to do here. On these, we're really just, we're still converting, but we're going to write both as fractions and then compare. So just to practice, so 7.7 is 7 tenths. If I want to compare that to 2/5, I might want to go ahead and write 2/5 as 4 tenths. That's multiplying the numerator and denominator both by 2. Then I can see, it is greater than. So if I know that 0.3 repeating is 1/3, and I should know that, you could get a common denominator over here, but most of us know that if you have one piece out of 3, it's going to be bigger than one piece out of 4. So you could go ahead and just put greater. But if you prefer to have a common denominator, to just see it more clearly, 1/3 would be 4/12 and 1/4 would be 3/12. So that's just an option. Scroll down and do our last 2 problems. Let's see. So you count tenths, hundredths, thousandths. So you've got 8 1/1000th. You could either change 1 over 125 to have the same denominator, but I recognize that this simplifies a little bit. So let's divide the numerator and denominator both by 4. Remember, we learned that if the last 2 digits are divisible by 4, then the whole number is. And 0, remember, is divisible by all numbers. So 4 into 8, and 4 goes into 100 25 times. So I have to add another little 0 on here. It's like I'm dividing it into just that part and then sticking on the 0. And 2 goes into both of these. So I see, they're equal. And then the last one over here, 0.25. Hopefully you have memorized that that is 1/4. That's one that's on the sheet to memorize. So you wouldn't actually have to write 25 over 100 unless you needed to. And 1 out of 4 pieces is actually bigger than 1 out of 5. So a greater than symbol. Well, I hope you have fun converting decimals converted into fractions.